Kotlin 2.3 introduces explicit backing fields, and it's a great feature, but it's also one that could take you by surprise if you don't know what to expect. So today we'll look at what it does and what to watch out for. But first, let's see why you might want to use explicit backing fields. A critical concern in software development is how we manage changes to state so that those changes can happen in a predictable way. And one common approach, especially in object-oriented programming, is to control the visibility of the state. So in other words, if we can make the data private to a single class, then we give ourselves some guarantees about how it can and can't change. We would only ever have to look at one class in order to see how and when the state changes. So for example, in this code, we've got a class for a doggy daycare, and it has two properties. It's got an ID, and it's got the name of the person who's currently managing the daycare. And the intent here is clearly that we're supposed to call this function anytime that we need the manager to change. But since this manager property is accessible from the outside, it's entirely possible to circumvent the onNewManager function. We can just set the manager property directly. To remedy this, we would often update the property so that it can only be changed from inside the class, and that's what this private set does. With this change, the compiler won't let us set the manager from outside the class. As you can see down here, we now get an error. Well, sometimes we're not concerned about changing the value of the property itself, but the contents of that property. So for example, while there's only one person ever managing the daycare, you might have several dogs who can attend the daycare at the same time. So instead of a single string property, as we had done with the manager, here we're using this mutable list to represent the dogs who are attending. And just like the manager property is updated by this onNewManager function, we've got these two functions that update the dogs list whenever a dog arrives or leaves. Now, unlike our original manager property, there's no danger of the instance of this dogs property changing because it's declared with val. But there is a risk that the call sites could add or remove dogs without going through the two functions. We can just call the add function directly on the mutable list from outside. So now you can sneak a dog into daycare without going through the front door. Well, one way to set some boundaries for this dogs property would be to make the mutable list private and then only expose it publicly as a regular list type. And since the add function isn't part of the regular list interface, you can see we get an error down here now. So by using a mutable type inside the class and a readable type outside the class, we've set up some guardrails for this list. With this change, this private underscore dogs property is known as a backing property because it sits behind the public dogs property. Now, it can seem a little unnecessary to have two properties, underscore dogs and dogs, that both represent the same object instance. The only difference is the declared type, and this is where Kotlin 2.3's new explicit backing fields feature comes in. It allows us to cut this down from two properties to a single property. Since it's still an experimental feature, we first need to enable it here in our build file with this compiler option. And once that's enabled, we can replace our two properties with a single property that looks like this. And this line tells us that dogs is a public read-only property, which has a public type of list, but that behind it sits a mutable list of strings. And in fact, if we really want to be explicit about it, we could specify the type manually like this. And by the way, if you prefer, you can put these on separate lines like this. And I kind of like using the type inference here, so I'm going to remove the explicit type specification. One of the neat things to notice here is that inside the class, anytime we refer to the dogs property, it gets smartcast to the underlying type. So in other words, it's referring to it as a mutable list, as you can see right here. But from outside the class, down here in the main function, you can see its type is just a regular list. So this allows the property to have a more specific type inside the class and a more general type outside the class. Now, there are a few very important things that you need to keep in mind about explicit backing fields. The first is that the public and private types have to be related. So the type of the field has to be a subtype of the type of the property. And technically, they could actually be the exact same type, but of course that would be pointless. If you were going to do that, you would just use a regular property instead. Another thing to note is that this only works for a property that's declared with val. If you were to change this to var, you'll get an error. Also keep in mind that, like all fields in Kotlin, explicit backing fields are only ever private. So even a subclass of daycare would not get the smartcast that daycare itself is getting. Even though an explicit backing field allows your data to have a different type internally versus externally, there's nothing preventing a developer from manually casting back to a more specific type. So for example, we can cast the dogs list back to a mutable list and sneak Max back into the daycare again. So with explicit backing fields, the public and private types differ, but the object instances are always exactly the same. Now, for some developers, those who have a particularly strong emphasis on correctness, this might be a deal breaker. And if that's you, you might prefer the previous approach of using a backing property so that you can ensure that your call sites won't abuse your API. So for example, you could return an unmodifiable version of the list or a copy of it. On the other hand, a lot of developers have argued the point that we spend a lot of effort protecting us from ourselves, and that a responsible developer hopefully wouldn't abuse an API by casting to a more specific type that allows changes where they're not intended. It all depends on what you and your team value and the risks involved in each situation. So for example, if your project is a library where you need to make sure that your code is used as intended, you might prefer to continue using backing properties like this. But for those cases where you're not worried about the call sites abusing it, explicit backing fields could be a good choice to reduce some boilerplate. As I mentioned earlier, this is still an experimental feature, and I'm sure the Kotlin team would love to hear your feedback about it. And you can provide your feedback on utrack ticket KT14663. Hey, by the way, if you're new to Kotlin, I've got a 1-week starter course coming up on February 9th to 13th. Every day during that week, I'm going to publish another video lesson to help get you introduced to the language. It's free, but you got to sign up for it. We've got a few hundred of you registered already, and if you're interested, I'd love to have you join as well. I left a link to the sign-up form in the description. Now, this starter course is for those who are new to the language, so if you're already rocking and rolling with Kotlin, you might want to consider inviting your newbie friends instead of attending yourself. But either way, look for the sign-up link in the description. All right, that's it for now. More videos are coming soon. I'll see you next time.